So good morning student. Today we are going to see about the topic disk scheduling. So before going to see the disk scheduling algorithm, so first we have to give the overview of the mass storage structure and how the disk mechanism is working. So this is your diagrammatic representation of your disk. So here the each and every platas, this is your platas. So these and each and every plata is subdivided into the circular tracks. So this is your track. So this is one track and this is another track. So like this, each and every plata divided into the circular tracks. The tracks the further subdivided as a sectors. So this is one sector, this is another sectors likewise. So set of tracks that are at the one arm position is called as a cylinder. So this is one set of track that make as a cylinder. This is one cylinder, this portion. Okay, so each and every plate are having the read and write heads that is attached with your arm assembly. So the center of the portion is called as a spindle that is used to rotate your disk. So now we have to know about some basic terms. What is transfer rate, seek time, and rotational latency? So transfer rate is nothing but the data flow between your drive as well as your computer. So how much time it will take the flow between computer and then drive. Then seek time. So what is seek time in the sense? It's necessary to move the disk arm to your desired solution cylinder. So this is our disk arm. So how much time it will take to move the disk arm to the desired cylinder? That is nothing but seek time. Then rotational latency. So how much time taken for the desired sector to rotate to your disk head? Suppose this is our desired sector is nothing but. So we have to rotate this sector to our head. So how much time it will take to rotate from here to here? So that is nothing but rotational latency. So OS have to use our hardware in an efficient manner. So that is the responsibility of the OS. So for the disk drives, we have to maintain the fast access time as well as the large bandwidth. Then only we can utilize our hardware in an efficient manner. Okay. So if you are taken the access time, it contains the two further components. That is nothing but the seek time and rotational latency. Based on the seek time and rotational latency, we can able to calculate our access time. So obviously our seek time must be the minimized. So then only our access time should be in a fast manner. And second one is the bandwidth. So bandwidth, how we can able to calculate in the sense, so total number of bytes transferred, so divided by total time between the first request of service and then completion of the last request. So this is the calculation for the bandwidth. So we can manage our access time and bandwidth by with disk input output request service. So how we are going to service our input and request, based on that only we can manage our access time as well as the bandwidth. So now these are all the 5 disk scheduling algorithms. So first one is the FCFS, first come first serve, and second one is the SSTF, shortest seek time first, and third one is scan, and fourth one is C-scan, that is called as the surplus scan, and last one is the look scheduling. So each and every disk scheduling algorithm having some advantages as well as the disadvantages. So now we will see one by one. So first come first serve, the name itself is there. What are all the requests coming first? We are going to be give the service for that. So for example, if you take on, so this is your queue, 98, 183, 37, 122, 14, 124, 65 and 67. So this is your input request. So here our headers start at the 53. So which request is coming first? Here 98. So directly the header is going to be moved from 53 to 98, then 183, then 37. So likewise this is going to be give the request. Okay. So if you take on the total head movement for this example, so it's totally 640 cylinders the head is going to be moved. So here and there it's moving, right? So that calculation is totally 640 cylinders it's moving. So how it's truly high, so the performance is very poor, I think so here. So but the process is very simple, so we don't need to calculate anything. So just what is the request is coming in which for order, so based on that only we are giving services. But the number of swinging, the head swinging is too high, so obviously the performance is going to be reduced. Suppose if we thought going to the directly 53 to 98, if we go to 37 and 14 first, then we solve the remaining request. So obviously the number of cylinders is going to be reduced much. So then obviously the performance also going to be increased. But that calculation we are not following under the first come first serve. So that is a drawback of this method. Then second one is the SST of shortest seek time first. So what is the shortest seek time means? So all the requests it's coming. So first we have to calculate which one is the closest to our head position. So before moving the far away. So what are all the requests is closest to our head, that is going to be served first. So then the remaining one by one it's going to be solved. So the same example if we are taking. So 53 is a starting position. So if you see the all the request, so nearest to the 53 is a 65. So it's solving. So 53 to 65, then 67, 37, 14. So likewise it's going to be solved one by one. So here the total number of the head movement is the 236 cylinder. So the first come first serve if you are taking, so totally 640 cylinders. So but in a SSTF, where the head movement is swinging only the 236 cylinder. So it is less like a shortest job first algorithm. So shortest job first, how we are moving. So each and every time the request is coming, we have to compare with the existing one. So which job is having the less number, so that we are going to be service first. Like the same fashion here also we are going to be managed. For example, the 53 to 65 is serving, then 67. Okay, so in between the moving to the 37, again the one request is coming for the 50. Now the 50 is going to be served first, then only it will move to 37. So just like a shortest job first. So each and every time the request is going to be compared with your head position, which one is having the less frequent less distance. So that is going to be handled first. So then only it will solve the remaining things. So compared with the first come first serve, the SSTF is giving a better performance. But here also, if you taken this, the same example, before moving to the 65, if we solve the 37 and 14 first, then if we move to the remaining means, obviously the number of head movement is going to be reduced. So normally the SSTF is giving the 236 cylinders head movement. Instead of it going to the 65 and 67 taking the first we solve the 37 and 14, then we go to the 65 and 67 means, so we can reduce the much head movements, that is a 208, only the 208 cylinders only we can able to move it. But we are not considering like that. So just we are calculating the distance between our from the current position of the head to the next request. So based on that only we are calculating just moving. So compared to the FCFS, SSTF is a better, but still it's having some performance issues. So that is going to be solved in a next algorithm, that is the scan. The scan algorithm is also called as the elevator algorithm. So why it is called as the elevator algorithm in the sense, so that disk arm is going to be moved at the one end. So first it will start to the one end and it reaches the end. Then again it is going back to the other end. So then again it's come back. So likewise, the head moment is going to be one end and reaches the other end. Again it has come back to the starting. Then again it is going to the other end. So likewise, the keep on the head moment is going to be front and back, front and back. So it is called as the elevator algorithm. If you see in this algorithm example, its starting position is 53. So move head is going to be start towards the left position. So until it reaches the 0, so then it go back to the other end. So 53 to 37, our request is going to be solved. Then 14. The after 14, there is no request is there. Still, the head is going to be moved and reaches the end. So once it reaches the end, then only it go back to the other end. So then 65, 67, 98, 122, 124 and 183. So then again it has to reaches 199. Then again it come back to the first position. Suppose the further any request, the 30, the new request is there. So it reaches 199. Again it comes to the solving the request here. Then 30. Then it reaches the 0. So likewise the head movement is going to the one end and other end. Again it has come back in. Then again it's go to the other end. So likewise the scan algorithm is going to be work. So what is the drawback here in the sense? The request have to wait a more long time. So how it's waiting the more long time in the sense? I already told, right? So here it's solving starting from 53, 37, 14, then reaches 0. Again it's moved to the right end. So after reaching here, the 65 is going to be solved. So in between that time, the 30, the request is coming means it has to wait. Okay. So it will reach 65, 67, then 122, 124, 83, then 199. So up to then again it has to return here. So in between the time any other request is coming, suppose 125 means it is going to be solved. Then again it's coming 100 means 100 is going to be solved. Then one by one it is giving the requests, everything is going to be solved. Then when it come to reach here, that time only the 30th request is going to be resolved. So up to that time the 30th request has to be wait. So waiting time is more here. So this is the disadvantages of the scan or elevator method. So we have to overcome this one to avoid the more waiting time for the each and every request. So for that purpose we are moving to the next algorithm as a C-scan. So C-scan is nothing but the circular scan. So how we are avoiding the waiting time here in the sense it provide the uniform waiting time. So how it's providing the uniform waiting time in the sense, just it start do the one end means it reaches the end. So here in this example the head movement is going to be moved first right hand side. So what are all the requests is there, it is going to be solved. Once it reaches the other end, then again it come back to the your starting position. So during this time, if any other request is given also, it won't solve. It's moving the head from other end to starting position. Then it will going to be solved again. So for example, the same thing. So once it reaches the 199, again the new request 125 is given also. So while coming the return back, it won't solve that request. It has to wait. So but in the previous, the scan method, so once it is reaches this end, again while coming back, the 125 request is given. So that is going to be solved. Then it come to the next step. So what will happen? So the which one is giving the first request, that is going to be wait more time. So that is going to be solved here under the circular scan. So while coming back, so whatever all the request is given, it won't solve. Again it reaches the starting end, then it's moved to again going to the move the right hand. So that time only it is going to be solve the remaining request. So the waiting time is going to be uniform for the all the request here. So this is your circular scan algorithm. The next one is the look, or otherwise called as the C look. So here both scan and C scan is moving the disk arm in a full width of the disk. So it is a full width of the disk in the sense, if you see here, starting from 53 to your ending position is 199. So up to that it's swinging. Then again it's come to 0. So but our request is what to only 183 here. Here only 14. But the head movement is swinging from one end to other end. That is nothing but your full width. So both scan and C scan is swinging the head from the full width of your disk from here into here. So this is totally, I think, unnecessary, since we have only the request is 183. So in this side we have request only the 14. So 0 to 14 there is no other request, but still it is swinging the head. So to avoid this one, we are moving to the look algorithm. If you see here, the same thing. So how the circular scan is following the same pattern, it's serving the request. So it first it start from the head, the right hand side, it's solving the all the request. Once it reaches the 183, it will stop and again it move to the other end. So if there is the no further request is there after 183, it won't reaches 199. It will stop and again it return back. While return backing, so without servicing anything, it is going to the beginning. Then what is the request starting from here? Only the 14th. The 14th onwards, it's going to be start the service. So it won't service after 193. So here it won't swinging after the 14th. So in this portion, we are going to be reduce the swinging your head. So this is nothing but your loop algorithm. It is continuously to move in a given directions. Okay, so this is your 5 disk scheduling algorithm. So each and every algorithm, we saw some advantages as well as the disadvantages. So now how we can able to select our best disk scheduling algorithms. If you see the SSTF, so comparatively the first come first serve, it's giving the better performance, but we cannot able to say is the out of all the 5 this is the best one, right? So if you take on the scan and C scan, it's giving the better performance for your system, but it's placing the heavy load on your disk. Especially if the scan algorithm, if you are taking, the starvation problem is coming. So what is the starvation problem? If the any request is coming, in the sense it's waiting a more time, the waiting time is very more in the scan algorithm. That is called as a starvation problem. So how we can able to select the best scheduling algorithm, in the sense the performances depends on the number as well as the type of our request. So based on the request only, we can able to select our best scheduling algorithm. So number of request as well as the type of request. So here the request for the disk services can be influenced based on the file allocation methods. How the files allocation method we are going to be managed, in the same fashion the here the request also going to be served. So after this, the disk scheduling algorithm is concept is going to be over. So we will see in the next video.